Hey guys, and welcome back for another lesson on surds. Today we're looking at surd fractions and rationalizing the denominator. I hope you joined us for our previous lessons on surds, particularly surd multiplication and division, because you should know that fractions are really just divisions. And in that lesson, we looked at surd fractions and how we should never leave an irrational expression in the denominator, because that would just be absurd. Get it? Absurd.
That joke was absurd.
Okay, so for this lesson, you're going to need to be able to multiply and divide surd terms as well as expand surd brackets. If you're not familiar with those topics, I'm linking them down in the description box for you below, so check those out before we get started. But if you've already seen them, let's get into it. After our lesson on multiplying and dividing surd terms, you will have learned that we can never leave a fraction in the form where we've got an irrational term in the denominator. Now the 2 is fine because this is the rational part of this term. However, the root 7 needs to be rationalized. Remember how we do that. If we square a surd term, that will make it rational. Because if we squared the square root of 7, those are inverse operations. They will cancel each other out, leaving us just with 7. So we don't need to worry about the 2, but let's multiply the denominator of this fraction by root 7. Now, remembering what you must have learned years ago about equivalent fractions, if we multiply the denominator of the fraction, we must multiply the numerator of the fraction as well. So we're multiplying both the numerator and the denominator of this fraction by root 7. Again, from our lesson on multiplying and dividing surd terms, you'll know that if I multiply two irrational terms together, root 3 times root 7, I can just multiply 3 and 7 together and put them under the square root sign. And you'll know that multiplying root 7 by itself will rationalize that root 7, making it 7. So we've got the square root of 21 over 2 times 7. 2 times 7 is a rational number now, it's 14. And I now have a fraction which, although I have an irrational numerator, the denominator is now rationalized. So long as I can't simplify this fraction any further, this is my simplified answer. Now, some people might think 14 divides by 7 and so does 21. But this is not 21, this is the square root of 21. I could divide by the square root of 7, but then we'd have to divide the denominator, 14, by the square root of 7. And then we're back where we've begun with an irrational denominator. So that's my simplified answer. And again, that should be nothing new, provided you've seen our previous lessons on multiplying and dividing surd terms. Our new learning objective for today is to rationalize denominators of fractions where the denominator involves an expression of more than one term. In this case, I've got the rational term 2 plus the irrational term root 3. And what some people mistakenly do in this case is they don't worry about the rational 2, but they want to rationalize the root 3, so they multiply the denominator and numerator by root 3. Now that rationalizes the root 3, making it the rational number 3. However, multiplying the 2 by root 3 will make it irrational, 2 root 3. So that's not going to help us rationalize the denominator. We're going to need to multiply both of these terms in the denominator by some set of brackets. But don't think that squaring the denominator, so multiplying 2 plus root 3, by itself will rationalize this denominator. That's not the same thing as simply squaring the 2 and squaring the root 3. You should know by expanding brackets, we need to multiply those brackets out twice, and you'll generally end up with either a 3 or 4 term expression from that, as well as the 2 squared, so 4, and the root 3 squared, so 3, you'll have a middle term, which will be a combination of 2 times root 3 and root 3 times 2. So that's not going to work. But if you're familiar with expanding brackets and particularly quadratics, you should be familiar with dots. Again, I'll link some lessons down below for you. Dots is the result of multiplying two brackets together, where the first set of brackets has got two terms which might be added or subtracted, and the second set of brackets might be the same two terms, however, the sign between them is the opposite. So in this case, 2 plus root 3 multiplied by 2 minus root 3 will result in a dots expression. If I multiply the denominator by 2 minus root 3, I better multiply the numerator also by 2 minus root 3 to keep this fraction equivalent. Now, don't worry if your numerator works out to be irrational. What we're trying to do here is simply rationalize the denominator. Expanding out the numerator, I would get root 3 times 2, so 2 root 3. And root 3 times negative root 3, rationalize that to make it negative 3. In the denominator, don't think that this is just 2 times 2 and root 3 times root 3. This will be 2 times 2, which is 4. 2 times negative root 3, which is negative 2 root 3. Root 3 times 2, so that's plus 2 root 3. And root 3 times negative root 3, which is negative 3. Simplifying that, I see that I have a 4-term expression in the denominator. However, the root 3 squared is the rational number 3, and the two middle terms are like surd terms. They both have 3 under the square root sign, so I can group them together. Negative 2 root 3 plus 2 root 3 will give me 0 root 3, or simply no term in the middle. My numerator, as you can see, remains irrational, although the root 3 squared became rational 3. And my denominator has become rationalized. The irrational parts have canceled themselves out, and the root 3 was squared, making it rational. This is the difference of two squares. Difference means subtraction. There's two terms, and both of those terms are the squared value of the terms in the original expression. 2 became squared, and root 3 became squared. And I've minused them. One more step to simplify that, 4 minus 3, that's 1. So I've got a rational denominator. In fact, any value over 1 will remain the same. So I could simply say that 2 root 3 minus 3 over 1 is the same thing as 2 root 3 minus 3. So I've rationalized the denominator, and I even managed to take it one step further to eliminate the fraction altogether. This will not always happen, but if it does, make sure you simplify as much as possible. Let's try another example. Remember, we don't need to worry about rationalizing the numerator, but we need to ensure that the denominator gets rationalized. And as there are two terms in the denominator, we know that this is going to happen by bracket expansion by use of dots. So just focus on the two terms in the denominator. And let's put that in brackets, and we'll write that same two-term expression, but with the opposite plus or minus sign between those terms. So 1 minus 2 root 5. Again, if I multiply the denominator by 1 minus 2 root 5, I must multiply the numerator by the same thing. So times 1 minus 2 root 5. The denominator is going to get rationalized by this, but don't think that the numerator will also be rationalized. Remember, the denominator will only be rationalized because the first term will be squared, the last term will be squared, and there'll be a minus sign between because the middle terms will have canceled themselves out. In the numerator, that does not happen. If I do 1 times 1, that gives me 1. Then I do 1 times negative 2 root 5, which is negative 2 root 5. Then I do negative 2 root 5 times 1, which is another negative 2 root 5. And then I do negative 2 root 5 times negative 2 root 5, which would be 2 times 2 makes 4, and root 5 times root 5 squared being 5. In the denominator, it looks very, very similar. However, because of the opposite signs, my middle two terms are minus 2 root 5 from doing the 1 times negative 2 root 5, and plus 2 root 5 by doing the positive 2 root 5 times the 1. And then my last term looks the same as above, except it's negative, because I did positive 2 root 5 times negative 2 root 5. Simplifying this down, we can group like terms in the numerator, so negative 2 root 5 minus 2 root 5, but that won't eliminate it. And the last term can be rationalized. 25 is a square number, so that's going to be 4 times 5. In the denominator, the middle two terms will cancel out because they have opposite signs and they're the same value. Negative 2 root 5 plus 2 root 5 is 0. And again, we can rationalize our last term because 25 square roots to become 5. so negative 4 times 5. Again, we can simplify that by multiplying our rational parts together. 4 times 5 is 20. And we can simplify that a little bit further by grouping our like terms. That is, grouping our rational number terms. In the numerator, I've got 2 plus 20, 22. And in the denominator, I've got 1 minus 20, negative 19. So here's my simplified surd fraction. The denominator is now rational, so I'm happy with that. The numerator may not be rational, and that's okay. If I were to try to rationalize the numerator, I would end up making the denominator irrational again. So let's leave it like that. That's simplified, and that's fine. You may try putting something like this into your calculator, however, and you get this answer. It's the same thing, and you should get the same marks for it. The only reason your calculator might give you this answer is because calculators tend not to want to give you a negative denominator. So I've changed the signs of the denominator and of the numerator. Multiply this by negative 1 and multiply this by negative 1. My negative 4 root 5 became positive and my positive 22 became negative. Again, either answers should be fine. However, this is the answer you'll tend to see on the calculator and tend to see on mark schemes. I hope you've taken a minute to copy that down and think that through, because here comes the practice exercise. You're going to need to take your time with this. Please don't use a calculator. It's not going to help with your understanding. And these surd questions are often asked on exams in algebraic form, or they're worth more than 1 mark and you get marks for your working. So take your time, copy the question, remember how to use dots to rationalize the denominator, expand those brackets out and simplify as much as possible, and hit play when you're ready to take up your answers. I hope you've had a chance to hit pause, because here come your answers. Question 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. How did you do? Hopefully you did well, but if you've made any mistakes, or you have any doubts, or you think I've made any mistakes, please leave me a comment down in the comment section, and maybe I can help you out with that. Otherwise, I hope you've enjoyed this lesson, found it interesting and helpful. If so, please give a like, make sure you subscribe, keep practicing, and I'll see you soon.